Hello and welcome to week 3 of the year 6 into 7 intermediate questions. Hopefully we know the format nicely now, so I'll leave the questions here for you to have a look at, pause the video, have a go, and then I'll flash the answers on the screen in a sec, which you can then mark your work and have a little look through to see how you've done and maybe make some corrections, and then I'll go through each question in turn. And again, I'll cross off on the left hand side the questions that I've done them to make it easier for you to flick through these solution videos. Okay, so if you pause now, okay, and here are our answers. So again, if you want to pause and remembering again, just go back maybe and see if you can find where it went wrong. If you've got last week's work marked as well, that'd be brilliant, because a lot of these questions are very similar indeed. And each week we just go a little tiny step on, make them a little bit harder. Okay then, so let's get into a walkthrough of these questions then. So question 1, doing a subtraction of fractions. So we just want to put in place some checks that we're going to do before we add or subtract any fractions. And the first one is, do we have the same denominator, so that number at the bottom? Are we talking about equal parts that we're going to take away from each other? And the answer is currently no, because if I was to draw this picture out, I would have a circle. It's a very thick pen, isn't it? And I would have this broken into 6 bits. So I'll start with, it's really worth drawing these out because you can see how fractions relate to each other. So I started with thirds there, because now if I half my thirds, I get sixths. Okay, they're meant to be equal parts. So I'd have 5 of these. And from those 6, I want to take away 7/24. Now I won't draw that out, but I would have a circle with 24 parts. Okay, so in fact I could take my 6's here and break each one of those up into 4 bits, and that would make 24ths. And that is the key to this. Okay, so at the moment I have the chunks here are too big. I have 5 large chunks of something and I want to take away 7 smaller chunks. I need to figure out how they relate to one another. So what I need to do is have a look at this fraction and say, could I figure out, if I shaded this in, let's take a different color. So if I shade in the 5 parts here of the 6, how many 24ths would that be? So let's have a closer look at one of these chunks here. Okay, so currently this is a 6th, and as I go round, I'd have 1, 2, 3, 4, 5, 6. So if I wanted 24ths, I say, well, what could I divide my 1/6 up into? Remember, it's all about equal chunks. So that if I have an equal amount of 24ths in each one of these, how many would I have to have in each bit? And in fact, the answer to that is 4. Okay, so if I put 4 equal chunks into the first 6th, and 4 in the next one, and 4 in the next one, and so on, I'd have 4, 8, 12, 16, 20, and 24 equal chunks, which conveniently all place themselves nicely into this shaded region that I've already got. Okay, so my question is then, how many would 5ths of these 6ths be? Well, let's count through our shaded bit. So this would be 4 of my 24ths. This would be another 4. So I've got 4, 8, 12, 16, and 20. So I would have 20 24ths. And that's what we call an equivalent fraction. That is exactly the same as 5 out of 6. Let's have a look at that again without having to draw a picture every time. So we're looking to try and change the 6 into a 24. So if I start with my 5/6, I needed to break my 6ths up into 4 bits each, and that got me to the 24 bits I needed. So I'm going to do that. How many of my 5 of those 6 would be worth, or how much would it be worth? I need 4 of those as well, because we broke each one of the 5 up into 4. And I get 20 of my 24ths. Okay, so we have now here, as we said before, an equivalent fraction. Now we're ready to do the subtraction, because we can say, right, well, if I've got 20 24ths, and I'd like to take away 7 of those same and equal 24ths, well, now I can just do 20 take away 17, which is 13 24ths. Okay, so the really important bit with fractions, for addition and subtraction, is make sure we're talking about the same parts. We're living in the same world, I always say. So we're living in a world of 24ths here. Okay, so we need the same denominator To figure that out, we need to say how many times does 6 go into 24? That's the equivalent fraction part here. So we do this little piece of maths to the side. And once I've got that equivalent fraction in 24ths, I'm now ready to do that subtraction. Okay, you did that by yourself already in a really good place, and you should probably be trying the advanced questions. All right. Okay, so our answer there is 30 down to 24. Okay. Right, question 2 then, how many meters are there in 1,430 kilometers? Now, we've spoken about this a lot. We've had these questions. Okay, so we know that 1 kilometer equals 1,000 meters. Okay, so we can do our calculations both ways to change from kilometers to meters. I can see that I times by 1,000 with the actual physical number. And from meters back to kilometers, I divide by 1,000. Because 1,000 divided by 1,000 is 1, and 1 times 1,000 is that. So once we've got that connection, we can just apply it over here. So we've got 1,430 kilometers. It's a lot of kilometers. How do I change that into meters? I times it by 1,000. Okay, so we're going to have 1,430, and then if I times it by 1,000, it will go 3 places to the left in our units. So in our place values. Okay, so that will leave space now for 1, 2, 3 placeholders. So let's have a look here. Let's try and break this number up and say it. I have 1,430,000 meters there. Okay, right. So write down the first 4 terms of a sequence that has a first term of 4 and a rule plus 10. And when we say a rule with a sequence, we mean between 2 consecutive terms. Okay, so I start with the number 4. Here we go. And I'm just going to add 10, and I want the first 4. So that's 4, add 10 is 14, add 10 is 24, add 10 is 34. And there we go, there's our first 4 terms of our sequence. Nice easy question, that one there. Next one, divide 967 by 4. Let's go for a bus stop. Just to say, if you like mental challenges to this, if you want to divide something by 4, or into 4 parts if you like, you can halve it twice. So let's have a look at why. So we start with a circle. I want to break something into 2 parts, draw a line down the middle. Once I've got my 2 parts, if I halve both of those, that's the same as dividing into 4 equal parts. Okay, so if you halve something and halve it again, you end up with dividing by 4. So you could do that if you wanted to, because halving is quite easier to do mentally. So let's do our bus stop anyway. So 967. How many 4s are going to go into that? Okay, so 4's into 9. That goes twice. 4 times 2 is 8. Remainder 1 left over from 8 up to 9. 4's into 16 is 4. And 4's into 7 doesn't go a whole amount, but it does go in 1 whole. So now we just need some more digits to carry our number onto. Okay, so we've got 4 into 7 goes once, remainder 3, because 4, 5, 6, 7. So we place down what actually is there, which is a decimal point, and then a 0 to carry our 4 onto. So to carry our 3 onto that we've carried over. So 4 into 7 goes once, remainder 3. 4's into 30. Well, 4 times 7 is 28. So there's 2 left over. So again, I'll place another 0 and pop that 2 down. 4's into 20, goes 5. So it's 241.75 for that. Okay, so if you're doing a division and you run out of numbers to divide by, but you still have a remainder, put a decimal point down and just add as many zeros as you want, because that doesn't change the value of the number. That's still 967. Okay, simplify the ratio 44 to 8. So we've spoken about these as well, and we've used the ratio a lot in various different questions. So when we say simplify, what I say is, what ratio did this start as? Okay, so currently we're dividing up 44 plus 8. So we're dividing up, 52 parts here. And we want to know, what did it start like that? So here's £52. What was the original quantity of money that was being divided up in an initial simplified ratio? So the way to do that is say, well, how small can I make this so that both numbers are still whole numbers? So what goes into both of these? Well, 4 goes into both of these numbers. So let's make both these numbers 4 times smaller. So we divide them by 4. So you see it's in proportion, whatever we do to one number to the other. That gives me a 2. and an 11. Okay. Is there another number that goes into both of